Okay, 170404 document, first problem given the system, asked to write it as a matrix equation. Now, I've written I equals 1, 0, 0, 1, the 2x2 identity matrix, just for reference. I didn't specify that in the problem. And, you know, when we're first getting into this, it's probably worth specifying this is the identity matrix. Okay, so now we've got this system, and this identity matrix isn't yet relevant. It will become relevant later on. We got this system, and we want to write it as a matrix equation of the form y prime equals AY. A being a matrix. Okay, well, y is going to be the vector y1, y2, the vector whose, the column vector, whose rows are y1 and y2, the functions y1 and y2 that solve this system. So, the equation becomes then, well, y prime, if y equals this, y prime is this, just going to be y1 prime, y2 prime, and the A matrix is going to be this, because when this matrix is multiplied by y1, y2, well, 2, 1 multiplied by y1, y2 gives us 2y1 plus y2. Negative 2, 5 multiplied by y1, y2 gives us negative 2, 1 plus 5, y2. And from what went before, what was done in the preceding class, everybody did that correctly. Okay, now, we have then y prime equals AY, where A is this matrix. Now, we're going to assume a solution. Okay, we're going to assume a solution to this equation of the form e to the lambda t times an x1, x2 vector, where x1 and x2, I didn't write it down here, but x1, x2 are just constant numbers. Okay, so this is very similar to what we did in solving second order equations. We assume that y equals a e to the lambda t, or c e to the lambda t, or b e to the lambda t, some multiple of e to the lambda t, and we plug in and we get a characteristic equation. Okay, so just a constant multiple of e to the lambda t is what we've done. Well, this is a constant multiple of e to the lambda t, but now it's a multiple with two components in this case, because of course we need to get a vector, our y vector has to have two components. So the y has to be a y1, y2, and y1 is going to be e to the lambda t times x1, y2 is going to be e to the lambda t times x2. We don't need to think about that right now. Y is of this form, and this is a constant multiple of e to the lambda t, where our constant is a column vector of the same length as our y vector. Okay. So, what's our y prime? Now, people had a little problem doing this because people aren't used to the calculus, aren't yet used to the calculus of matrices. Although that was assigned for today, we'll see how people did on that. Okay, we have our y prime then equal to what? Well, there's a product rule. It's not necessary to use a product rule because this is a constant, but we're going to see what we would do if this wasn't a constant, just so we put this in the context of general calculus of matrices. Okay, so this is a product, so we're going to use a product. We're going to take the derivative of e to the lambda t times our x1, x2, plus e to the lambda 2 times the derivative of our x1, x2. Well, the derivative of our x1, x2 is just, you're going to have the derivative of x1 here and the derivative of x2 here. Since x1, x2 is constant, meaning x1 is some number, some fixed number, x2 is some fixed number, those derivatives are going to be 0. So this is going to give us the 0 vector. And I say, you know, a little careless, and I'm trying to be pretty careful here about putting vectors over 0 vectors. This becomes the 0 vector. And e to the lambda t times the 0 vector is still the 0 vector, so we can neglect this. And our y prime is just going to be the derivative of this times the x1, x2. Now, as I said, when you see this in the future, you're just going to think, okay, that's a constant. Just take the derivative of this times that constant, because you bring the constant out of the process of taking a derivative. In the derivative of e to the lambda t, everybody knows is lambda e to the lambda t. You've done that a million times by now if you've done everything. So we get this times our x1, x2. And then we can write that as lambda e to the lambda t times an x vector, where the x vector is the vector with components x1 and x2, constant vector with constant components. Okay, so now we've got the derivative of y, and we've got y. So what's the next thing we do? Well, we plug this assumed solution into our equation. Here's our equation. Now, you should do that. I'm going to split the video here, and I'll come back and do that in a minute.